Welcome to this video where we're going to see a library of extras, which is very important in order to create digital twins in manufacturing. So let's start and let's open SIMIO. Well, we open SIMIO now and we model a process which is made of a source, and then we have two servers in a flow, one after the other. Then we have some kind of storage place after the server number 2, and then we have a sink. So we place the sink, and for now the storage place, we don't know exactly what it is. So now we connect the source and server number 1. We connect server 1 and server 2. And as I said, we have something between server 2 and the sink, which is kind of this storage place. So let's model that in the way it should be modeled in a manufacturing process. We need to open the extras library and place a rack. A rack is a shelf or a collection of different shelves, which then contains different entities. It's a very, very good item to be used in manufacturing processes. We connect server 2 to the input of the rack and the output of the rack to the sink. So how big is the rack? So it has 4 shelves, for instance, and it has a capacity of 5 entities per shelf. We can select, for instance, that we always load stuff on the shelf with the lowest number of entities. And when we run the simulation, you see that the shelf is composed. And if you run the simulation, you also see that entities are placed in the right place on the shelves that are less used. So now we want a robot arm to move stuff from source 1 to server 1. In the extra libraries, we have robot arms. We drag and drop it, and this is essentially placed, for instance, at the output of the source. This is the home node for the robot arm, where the robot arm will pick up things. Now we do some adjustments to the path. We make it bidirectional, and to the source we change the inter-arrival time to 2 minutes, exactly 2 minutes, so we can appreciate how this works in a better way when we run the simulation. The robot arm has different types of properties, not many in fact, and it has different advanced options for animation. So the robot arm is essentially a transporter, a vehicle. So if we look at it right now, if we run the simulation, we can see the robot arm to be displayed. But if you look at carefully now, when I run the simulation, the robot arm is not moving, it's just a static thing, and we don't like that. So we would like to use the robot arm in an animated way. As said, this is a transporter, so we have to enable the logic of riding on a transporter, and we need to select the robot arm to be the transporter. So if you run the simulation now, this is not exactly, this is not precise, but at least the robot arm is moving, and in some way it replicates our robot arm is in fact behaving inside a manufacturing process. So not the best animation, to be honest, but the next step it will be better. So first of all, I would like also to introduce what is this entity. So this is a box, and we can very much apply a symbol of a box from the standard library that we have here in SIMIO. So let's run the simulation again in 3 dimensions to see what happens. At least the robot arm is moving, is picking up the box, and the box is traveling to the server. But the animation, the default one, is not great. That can be changed, in fact, if you like. But in many cases, it's just enough to have the robot. So let's see what happens between server 1 and server 2. Now we want to use a crane, but before we use a crane, we need to define where the crane is moving. We have to drag and drop what is called a bay. So this bay is the gray rectangle that you see here, and the bay should encompass both the output node of server 1 and the input node of server 2. If these 2 nodes are outside the bay, the crane cannot operate. Once you have the bay, we can drag and drop the crane. And we can say, for instance, that its initial node is the output of server 1. So the crane is pretty large, it's pretty big, and it has different properties. So first of all, to make it work good, we make the path to be bidirectional. Also, we have to do something else. We need to select the destination type to be specific, specifically the input node of server 2. Otherwise, this is not gonna work properly. So this is different. It's not continue destination type, but it's very specific one. The cranes just needs that to operate. So the crane is also a transporter, so we need to activate ride on transporter, and we need to select the crane. So now we can run the simulation on 3 dimensions, and you see the crane, you probably notice, is animated quite well. So it goes down, it picks up things, it moves it to server 2, and it continues like that. This is pretty neat, in fact. So now let's move to the final stage of this mini process. So we move stuff between server 2 to rack 1, and to the sink using a forklift. We drag and drop the forklift, and let's say that its home node is close to the input of rack 1. So the forklift, or the lift truck, it has a capacity of 2, but we can use more functions to define it, more specific and advanced functions. It has a load time, and it has an unload time, which is probably longer because we have to be careful when we place things on our shelves. We can actually wait until the forklift is full before we move to the rack, and we have different speeds, not only for the truck but also for the fork to go up and down. So the lift truck is a transporter, so also in this case we have to activate ride on transporter, and we have to select it like that. So we also need to put to define paths as bidirectional, so the lift truck can go back and pick up things. So now in 3 dimensions we can animate the process. So the robot arm is not really well animated, the crane is pretty good, and the lift truck also is not bad. It's waiting for 2 boxes. These boxes are placed on different shelves according to the logic that we give. It takes a little bit more time for the upper shelves than the lower shelves. So this is quite important in the simulation. And we can continue running the manufacturing process like that to obtain a little bit more precise performances than just using the servers and the standard elements in the standard library.